This video goes through unit vectors in three-dimensional space. Now recall from when we were doing 2D, if u is the unit vector, then the unit vector denoted by u with a little hat on the top of it is given by the vector divided by its magnitude. And the reason is that unit vector has magnitude of 1. That's what it means. It's a unit vector, size 1. So we divide by the magnitude of u to make it that size 1. So if we're looking at 3 dimensions when r is xi plus yj plus zk, our unit vector r is going to be r over the magnitude of r, which can be denoted by, here is our r, and it's being multiplied by 1 over the magnitude of r. So you can just think about it instead of that way. You can do xi plus yj plus zk all over the square root of x squared plus y squared plus z squared. Now the reason we don't express it like this is our 1 over the magnitude will be a fraction, so it'll be outside the brackets. But that is what we're doing, the vector divided by its magnitude. So let's look at some examples. For each of the following vectors, calculate the exact magnitude of the vector and a unit vector parallel to the given vector. So first of all, the magnitude of the vector is equal to the square root of 1 squared plus 2 squared plus 2 squared, which is the square root of 1 plus 4 is 9, which is 3. So our unit vector is going to be our vector divided by its magnitude. So that is 1/3 times by I plus 2j plus 2k. So now you can see why that 1 over 3 is out the front. So try the next one yourself, pause the video, see how you go. So for this one, the magnitude of b is equal to the square root of 5 squared plus -7 all squared plus -1 all squared. So that's equal to 25 plus 49 plus 1, which is the square root of 75. That can be simplified as the square root of 25 times the square root of 3. So that's 5√3. Our unit vector b is going to be our vector divided by its magnitude. So that's 1 over 5√3 times by the vector, which is 5i minus 7j minus k. Let's look at another example. If the point P has coordinates -7, 3, -4, determine the vector OP. So my vector is in component form, so that's going to be -7i plus 3j minus 4k. The magnitude OP is going to equal the square root of -7 all squared plus 3 squared plus -4 all squared. So that's the square root of 49 plus 9 plus 16, which is a square root of 74. And part C, the unit vector parallel to OP. So that's going to be given by our vector P over the magnitude of P. So 1 over the square root of 74 times by -7i plus 3j minus 4k. Rationalizing that denominator would be square root of 74 over 74, -7i plus 3j minus 4k. Now just a note, some textbooks will write it as -7i with the hat plus 3j with the hat representing the unit vector. So just beware of that as well in terms of notation.